kinematics, and we'll try to solve some problems on that. So you know about free body diagram, right? So whenever you are being given about some sort of car or bike or whatever, any object, you'll have to transform it into a free body diagram, and then you solve problems. Okay? And when an object is at rest, what are the forces acting on the object? Yes. Any one force? Friction. Good. Okay. But it's static friction. Okay. Then what else? Normal reaction. Good. Weight of the object. Good. So when an object is at rest, the normal reaction will be equal to the weight of the object, right? And weight, can we call it as gravitational force? Okay, it's the force due to gravitation. So this normal force and the gravitational force gets cancelled out. So it is at equilibrium. There is no x direction movements. So it is at equilibrium. When an object is in equilibrium and we are adding one sort of extra force, what will happen to the object? It will gain an acceleration. Okay, that's Newton's laws. Net force is equal to mass of the object multiplied by acceleration. Okay, and if you know the value of the force, you can find the value of acceleration, and if acceleration has been given, you can find out the net force acting on the object. Okay. This is a system of 3 objects which are tied by 2 springs. The mass of the first object is 5 kg, and the second one is 3 kg, and the third one is 7 kg. Okay. Initially, these are at rest. Initially, the total system is at rest. Now, a pulling force of 45 Newton is given to the whole system. Now, can we find what is the tension on these 2 strings which are tied between the objects? And let's name them as T1 and T2. This problem we can take it in 2 ways. Okay, one is as a whole system and one as individual objects. Okay, if we take it as a whole system, what is the total mass of the system? So mass of the system, I am writing it as m/sys, it's 15 kg. Okay, the net force acting on the system, 45 Newton. Why it is 45? Because the normal reaction of 5 kg and the weight gets cancelled out. Similarly, for all objects, it's getting cancelled out. And the tension here, this will act this way on the 5 kg, and on 3 kg it will act in the opposite direction. And the values are same. The same string is exerting 2 forces, one on 5 kg towards left, okay, of the system, and 3 kg to the right. So they get cancelled out. Similarly, T2 is exerting a force on 3 kg in this direction and 7 kg in the opposite direction. So they get cancelled out. So initially it is at rest and equilibrium. So all the forces involved in the system are getting cancelled out by each other. So there is no net force. Now I am giving an extra force of 45 Newton. So that will be your net force. Okay. So by Newton's law, what is net force? F net is equal to mass of the system into acceleration of the system. Now 45 is equal to 15 multiplied by acceleration. What is the value you are getting? Acceleration is 3 meters per second square. Correct? So this is the acceleration of the whole system. So the individual components of the system will have the same acceleration, right? Or they will have different acceleration. They'll have the same acceleration, all the components inside the system. Now I am drawing the free body diagram of this 5 kg mass. Okay, let's take this as 5 kg mass. What are all the forces acting on the 5 kg? Okay, as we know, this is the gravitational force and the normal, which are equal. I am writing it as Fg and Fn. Then 45 Newton, which is being given, and the tension. In which way it is acting? Away, opposite. Okay. So this is T1, right? This is the free body diagram for 5 kg. Right? Now I am going to draw the free body diagram for 3 kg. Again, Fn. You should not ignore this normal force and the weight when you are drawing a free body diagram. Even though they are equal, you should add that in free body diagram. Okay? No, when it is at rest, we don't usually show friction. Okay? Initially it is at rest. Let's assume it is a frictionless surface. Now this 3 kg, what is the force acting on the 3 kg? Yes, it is a smooth plane. I said it is a frictionless plane. So it is smooth. What are the two forces acting on the 3 kg? T1 towards left, T2 towards right. Right? So this is for 3 kg. And for 7 kg, tension 2 is acting towards the left, right? So it is T2. Towards right there is nothing. So no force. So this is your free body diagram for all the 3 components in the system. Now let's take this 5 kg. We know the acceleration, right? We know the acceleration. What is the net force acting on the 5 kg?
45 minus 41 equals 5.
Good. So the net force will be 45 minus T1. Right? So let's split it like this. 5 kg, 3 kg and 7 kg. Okay? For 5 kg, F net is equal to 45 minus T1. Right? That's the net force on the x direction, 45 minus T1. And that is equal to mass into acceleration, right? Mass of 5 kg into acceleration of 5 kg. So it is 45 minus T1 is equal to m5 a5. So 45 minus T1 is 5 times. What is the acceleration? It is 3. Because the acceleration of system is 3, so the acceleration of 5 kg is also 3. So what do you get for T1? 30 newtons. Right? So T1 is 30 newtons. Now for 3 kg, it's T1 and T2. Either you can find T2 by substituting this T1, or we find T2 and then check whether what we have found out is correct or not. Okay? Now we will do it for 7 kg. So what is the net force on 7 kg? What is the net force on 7 kg? This T2. So T2 is equal to, okay, write like this. F net is equal to T2. So T2, which is equal to mass of 7 into acceleration of 7. 7 into 3. T2 will be 21 newtons. Any doubts? So T2 will be 21 Newton. Okay? Now let's go for 3 kg. What is the net force for 3 kg? T1 minus T2. Correct? So that T1 minus T2 should be equal to mass of 3 and acceleration of 3. What is mass? 3 multiplied by 3 again. That is 9. Correct? Now we will substitute the values of T1 and T2 which we have found out. It is 30 minus 21. Are they equal? So what we have found out is right. So this is how you have to solve this kind of problem, T1 and T2. Any doubts? Have you understood the whole problem? Any questions? Okay, fine. We'll move on to another problem. And now you're going to solve it. Okay? Try solving it. I'll give the problem. Now, okay. I want you to find the effect of 5 kg on 3 kg object. Okay? The effect which is given by the 5 kg object on the 3 kg object. See, okay, I'll explain. The system is having two components. One is of 3 kg and one is of 5 kg. And frictionless again. Just ignore friction. Just ignore friction. Now I am giving a force of 50 newtons. Okay? When I give 50 newtons, I am disrupting the equilibrium of the system. You're saying the acceleration value. Okay, just solve it. So now we are giving an additional 50 Newton force which disrupts the equilibrium and the system starts moving. Okay? The 3 kg object will give some effort on the 5 kg object. Similarly, the 5 kg object will exert an equal amount of force on the 3 kg object. I want you to find the 5 kg object's effort given to the 3 kg object. No, just the force. You can find the force, that's enough. Yes. 30. It should be 30. Guys, I told you to solve. You need to find the effect of 5 kg object over the 3 kg object. How can we go about this? As I said, the system is 3 and 5. Use the system to find the acceleration of the system. So what is the acceleration? How do you find? What is the net force on the system? 5 newtons is the effort which is given. No. It should be more than that. I guess it's near 30. Right. Okay, wait. As a system, what is the net force? 50 is the net force. 50 should be equal to mass into acceleration. Mass is h to A. A is 6.25 meters per second square. Right? This is 6.25. Now each 3 kg and 5 kg object will have the same acceleration. Now draw the free body diagram of 3 kg. This is force normal. This is force of gravitation. This is Just draw like this, 50. And the 5 kg is preventing it, right? It will give an exact opposite force. Not 50, you need to find this.
So 31.3.
Yes. That is nominal. Okay, good. So this is a free body diagram for 3 kg, right? For 5 kg. Ananya, can you draw the free body diagram for 5 kg?
I'm very good. Sir, I'm very good.
Sriram will draw the free body diagram for the 5 kg. Normal force. It will 5 kg. There is no interaction with the 50 Newton force with the 5 kg directly. See, this is 5. What are all the contact forces here? Its weight is a normal force, and we have the force given by 3 kg over the 5 kg. That is the only force. Guys,
So 15 Newton is being provided here. Here also 15 Newton.
see, that's what you need to give. This FR is what you have to find out. There is no right side, there is no left side force, right? It's only right side force is being given by the 3 kg object.
So 15 into 3 by 5.
You have to find it out. Just FR, write FR. That's it.
FR is equal to 15 into 5.
No.
15 to 3
I'll say how to solve.
15 to 3 by 5.
Guys, settle down. Very soft. So this is for 5 kg. Now for 3 kg, what is the net force? 50 minus FR, or the force which is given by the 5 kg to the 3 kg, which is equal to 3 multiplied by 6.5.